My name is Jordan Denise. I'll be presenting the abstract, background, and the uniqueness of our project. So first, I'll be talking about the abstract. So pretty much this motion sensor security camera, it will help keep home safe while at the same time allow individuals to save money on security systems that will cost a fraction of the price. Pretty much compared to other security systems, you're looking at probably roughly around 150 or even maybe up to $1,000 for a security system, which is unnecessary. So it's a little bit about the project. The technology behind this project is OpenTV, which is a library of programming functions mainly aimed at real-time computer vision. In addition to OpenTV, the programming languages that are being used in our project are Python, HTML, and JavaScript. Furthermore, the MQ2 gas sensor was also implemented along with an analog to digital converter. In addition to that, we also had to use a logic level shifter. Next, I'll be talking about the background with our project. One of the main reasons why we're able to complete this project is by using OpenCV, which is pretty much open source computer vision library, which is an open source computer vision machine learning software library. This library contains more than 2,500 algorithms, which includes sets of both classic and state-of-the-art computer vision and machine learning algorithms, which are used to recognize faces, identify objects, classify human objects in movement, and also track moving objects. In addition, this library is used by companies, research groups, and the government. In addition, OpenCV also contains C++, Python, Java, and MATLAB interfaces that supports Windows, Linux, Android, and Mac OS. OpenCV is written in C++. It has templates interface that works with STL containers. Next, I'll be discussing about the uniqueness of our project. Something that's really major in our project that most Raspberry Pi cameras don't have is the implementation of a gas sensor. So by adding a gas sensor, we're able to detect a variety of different gases, including one of the most deadly gases out there, which is carbon monoxide. The only issue is with an MQ2 sensor is that it only returns analog signals, which a Raspberry Pi can't pick up. So the solution for that issue was implementing an analog to digital converter, which can be read by the I2C square bus, which is on the Raspberry Pi, which can easily pick up the digital signals and output our values.
Hi, my name is Christopher Bissett Lee. I'll be presenting the design specifications, the tools we used, and the implementation details. For the design specifications, we set out a few design requirements that we wanted to make sure that our security system would follow through functionality. Some of those requirements that we wanted to try to make sure that it would achieve are to detect people, motion, and the various gases like LPG, smoke, methane, and carbon dioxide. And if any of these were detected, we would be able to relay this information to the user's email. Now to the right, we actually have a block diagram showing this very process. So both the sensor and the Pi camera would send its information directly to the Raspberry Pi, and the Raspberry Pi would take this information and relay it to the corresponding programs that it needed to be. Like in the gas sensor's case, it would be the sensor code. In the video's case, it would be sent to OpenCV, where it would constantly relay a live video to a local HTML page to the user. And at the same time, both of these codes would actually run checks to make sure if anything was detected. If not, it keeps looping back. If so, it sends it to the notification system, and it relays an email to the user. So onto the tools that we use for the project. So for the software side of things, we ended up using Raspbian Buster OS, so that way we could interface with the Raspberry Pi a little bit more effectively, being able to do it through the actual user interface and the terminal. We also used OpenCV and a full body model from Hackster.io to be able to perform image detection and be able to distinguish between humans and pretty much the environment. So that way we could determine what's being displayed and like what exactly is entering the frame. So primarily for programming languages, we used Python specifically for modifying and being able to run our code on the Raspberry Pi. But we also used HTML and CSS because the OpenCV program that we had would send an actual live feed video to a local web page. So we modified it using HTML and CSS to make it a little bit nicer and cleaner. So lastly, for Python libraries, we ended up using the MCP 3008 library to be able to interface with the analog to digital converter, and the SMTP lib library we used to pretty much establish a connection between the Raspberry Pi and the mailing server, so that way we could send emails to the user if something was detected. So as for hardware, we used the Raspberry Pi, so that would be the brains of our actual security system. A specific Raspberry Pi camera called the Noir camera, which actually has an infrared module to be able to detect or be able to view things in the dark a little bit easier than regular Pi cameras. Lastly, we have pretty much these three objects that are pretty much primarily used for the circuit of the MQ2 gas sensor. And we used an analog to digital converter because the gas sensor that we were using outputs analog, and we needed an actual digital converter to be able to manage the data a little bit more easier. And we also used a logic level shifter, so that way we wouldn't harm the Raspberry Pi because the gas sensor would be sending out 5 volts and the Raspberry Pi could only handle 3.3. So for our hardware implementations, it was pretty easy to actually implement a lot of the hardware components because most of it was kind of plug and play. So in the case of the Raspberry Pi, we really only needed to plug it in through USB to power it up. But in our case, of course, we used a micro USB instead of regular USB, and we ended up connecting an Ethernet cable from the Raspberry Pi to our system or our laptop, so that way we could modify it and be able to connect through the network to our Raspberry Pi. The Pi camera didn't really require that much thought or labor itself, because all we really had to do was take the ribbon cable of the camera and slot it into the CSI module port. However, the one component that did require a little bit more labor to actually implement was the MQ2 gas sensor, because the gas sensor actually has an input voltage of 5 volts, and because it outputs an analog signal, it would be outputting an analog signal that was from 0 to 5 volts. And we can't really do this because if it's anything above 3.3 or if it hits 5 volts, it would actually damage the Raspberry Pi. So we had to use a logic level shifter to run the analog signal through and be able to convert that signal into about a signal that has a range of 0 to 3.3, which is a more manageable voltage for the Raspberry Pi. And of course, since we need an actual digital signal because it's a lot easier to manage digital signals in code, we ran the now converted 0 to 3.3 volt analog signal through an analog to digital converter using SPI connections to actually obtain that information. So that pretty much covers the hardware implementations of our system. So now for the software implementation. So when we were actually doing the image/motion detection portion of the software, we had to install OpenCV and its multiple directories, but we had to actually do so in a virtual environment, because if we didn't, it would potentially alter Python codes or things that we didn't want to alter, and that would potentially affect the gas sensor and its dependencies and libraries. So because we're running all the actual motion detection and image detection software onto a virtual environment on the Pi, it won't affect it, and the gas sensor's code won't actually be affecting the motion detection as well. So after that, we also utilized the full body object classifiers that we talked about before. So that way now, after we deposit it inside of its directory, we're able to determine what's human and what's the background. And of course, we modified the actual OpenCV code a bit so that way it was linked towards the email that we wanted it to send notifications towards. And we also modified the HTML code that the actual program itself would make, because since the actual program would make actually establish a web server onto the local network and actually relay the live video footage. We also modified the HTML and the CSS of that local web page so that way it would be displayed a lot nicer, and you'd be able to actually see the video feed a lot better. For the gas detection and alert, we actually took a pre-existing gas sensor code, and since we were able to obtain the digital values of the gas sensor, we created some gas value thresholds so that way we could understand when gas was actually being exposed or being detected. And by doing so, we linked our notification system that we created as a library, so that way whenever we triggered this conditional statement that if these threshold values were reached, it would call on this notification function inside the notification program that we had and send an email showing that smoke was detected. So something important to note is that both of these programs are actually done simultaneously. They're executed simultaneously. So we have one terminal that's actually essentially running a virtual environment for the motion detection, and then we have another terminal running the gas detection and its program, not on the virtual environment, but in its own terminal. And both of these are able to run simultaneously without affecting each other. So that pretty much sums up the software implementation.
So the result of this project was very achieving. We reached our goal on what we was trying to make with this project. We were able to make the camera work with a live feed, which we really wanted. We were also able to add the gas sensor, which works very good. The programming went really smooth. There's no lag to it or nothing like that. Also, when it sends our notification to the email, it also works very good, very smoothly, very quickly, which we also were trying to achieve in this project. The wiring also went very good. Everything wired up good, didn't give us a complication. Well, overall, the project went very good. The results that we were trying to achieve, we achieved in this project, and this prototype went very achieving, and I hope we can build on this. Thanks. We faced quite a few challenges while doing this project. One of the challenges we faced was with the OpenCV installation. Well, the challenges we faced with this one is that it takes about 2 to 4 hours to actually install it, and there was times where it kept messing up, and then you have to wait another 2 to 4 hours to reinstall it. Another challenge we had was with the analog to digital converter library. So what happened with this was we had to buy uh, another analog to digital converter chip, and at first we didn't know that we actually needed the library for it to actually work with the Raspberry Pi. So we were searching, and that took quite a few quite a few hours to actually figure that out. Another thing we had was we was having network issues with the firewall at FAU, which we will meet up at FAU in the cube and stuff to work on the project. And then there was times where like the VNC server would not open up because I guess there's a strict firewall with FAU, and it was causing mad problems. So we actually had to go back home to work on some certain parts, which made it longer time. Also, it was kind of our first time working with a Raspberry Pi, which at first kind of difficult, but I mean after a while we kind of got it kind of got a little easier for us to work with. But it being the first time, it was kind of difficult at first trying to do some of the programming and installing everything since we were kind of all new to it. And another thing was also getting the right equipment for everything to work. So like I said, it was our first time using Raspberry Pi, so we had to get an SD card, then we needed an Ethernet cable, We needed some wires that we were missing to actually make the gas sensor wire up properly. But that being said, everything was actually good after that. So all in all, this project was a very fun, challenging at times project. What we found was that the Raspberry Pi and our actual camera that we made was a very functional and flexible system. It's user friendly, so anyone can kind of use it. We also found that it being so small, it made it portable, which is very useful as you can move it around, you could actually put it in places, where it could be hidden and stuff like that. But what we were really trying to get out of this project was to make, something that makes life so much easier and so much simpler and so much safer. That's what we were trying to get out of this project. And I think we achieved it, making the security camera, knowing, if you're away, you could actually know what's going on anywhere you put the camera. And, with the gas sensor, if something happens, like a fire or something, you know that it will send you a notification. So that also makes life so much better. So all in all, we achieved a lot with this project. We learned a lot doing this also, which is a good thing because future in life, someone might actually want to do something like this, and this is a great prototype to start something with this. So I hope you guys enjoyed it, and we'll be showing our demonstration right after these slides.
So here we have the Raspberry Pi camera connected to the Raspberry Pi, and I'm gonna go ahead and run that code on the putty to show that it's working. So as you can see, we have the live security feed of the Raspberry Pi camera. Your camera did indeed pick up motion as well as my face when I was trying to steal some stuff. So now the gas sensor. The gas sensor here is connected to the level shifter, which is then connected to the analog to digital converter, which is powered by the Raspberry Pi. So I'm gonna go ahead and run the gas sensor code to show that it's working. It is picking up that there's smoke in the area. Picking up smoke. So now it's going to send a notification to the email. So let me go ahead and go to that email. I just received multiple emails about the gas sensor detecting smoke. The gas sensor and the camera to show that both the camera and the gas sensor works together. So here you can see that the gas sensor is done calibrating, and I'm going ahead and run the camera code.